So let's look at another one of these special right triangles where we have a right triangle where one of the acute angles is 45 degrees. If the angles of a triangle have to add up to 180, and this down here is a 90-degree angle, then that means these two angles have to add up to be 90. And if one of them is 45, the other has to be 45, right? 45 plus 45 is 90. So we call this type of triangle that has two congruent angles like so, we call this isosceles, right? So this is an isosceles right triangle. And in an isosceles right triangle that has two congruent angles, it also has two congruent sides. So no matter what this side length is, this side has to be exactly the same, right? So let's call this x and let's call this x. All right. So suppose I want to know what the length of the hypotenuse is. Let's use these values of x, and I'm just calling the hypotenuse c to remain consistent with the Pythagorean theorem. If we set up this equation, we have 2x squared, so we'll call that 2x squared, and that's equal to c squared. Now when I take the square root to find out how I can label this hypotenuse in terms of x, I get the square root of 2 times x squared, and radicals can be separated into the product of radicals, like so. And the square root of x is x, so we get radical 2 times x, which we usually put that non-radical number in front. So here's what we get for the length of the hypotenuse in terms of x, right? We get x radical 2. So in a 45, 45, 90 right triangle, special right triangle, the ratio of the sides is x to x to x radical 2. Okay, let's look at some examples.